Welcome back to Math Video Tutorials, and thank you for tuning in. And we're going to look at this exercise where we are looking to find the derivative of y equals 3 to the power fx. Now, if you have a logarithmic function or log function, y equal, let's do this, the natural log. This applies to any log-based function. Then the derivative of this function here is going to be, well, we call it y dash. It's going to be the derivative of the expression f of x divided by f of x. Okay, so that's how you differentiate the log functions. Now, for this one here, we need to first take the log of both sides, and we're gonna use the natural log, of course. So we're gonna do ln y is equal to ln 3 to the power x, and then we're gonna apply the power rule on the right hand side, which means that the power x will come out of the ln 3 to the x. So we'll have ln y, still the same on the left hand side, is equal x times ln 3. And then we're going to take the derivative of both sides. So we're going to say the derivative of ln y is equal the derivative of x times ln 3. And we're going to apply this rule, if you like, for this one here. So basically, we're going to say is y dash with the derivative of y divided by y, because remember y is a function of x, as we have here. And on the right hand side, I should not put the dash there, there's no need for it. And differentiated this is straightforward, is simply ln 3. Now allow me to rewrite this one here. I'm going to write it down as 1 over y times y dash equal ln 3. Reason is being that now I need to rewrite y dash in its formal state. Right, so basically it is same as dy by dx. So if I could replace it here, 1 over y times dy by dx, this is the y dash there, is equal ln 3. And then making dy by dx the subject will allow us to answer the question. So, and in order to do that, we just multiply by y. So dy by dx is equal y times ln 3, and therefore dy by dx, that's the solution now, the answer, is equal, now we know y is 3 to the power x, so we just have to substitute it there, times ln 3, and that is your answer. So now that we have seen how to differentiate a function such as this one here, we can write down a more general form such as y equal a to the x. So we've got a base a, so a is a constant. Then following from what we seen earlier, the derivative of a to the x will be a to the x times ln a. Right, that is the case all the time. The interesting variation for this formula, if you like, is when a is equal the constant exponential. If a is equal e, then we can write it down. Of course, this one will become e to the x, and that will give us a derivative dy by dx is equal e to the x times ln e. And because we know ln e is equal to 1, so this one is equal to 1. So basically doing e to the x times 1. So therefore the answer is e to the x. So whenever you have e exponential, the base is exponential e, then the derivative is, of course, it's itself, and we know that. What I'd like to do next is to take it from here and change the power, or make it more interesting or challenging. So instead of a to the x, we can still work with this one here, 3 to the x, but we're going to change x to x squared, and we can change it to, for example, sine x and things like that, and see how this will take us, and hopefully make a more general rule for all different type of exponential functions. All right, so let's do just that. So far we've seen that if a exponential function a to the x, where a is a constant, then the derivative of that exponential function is given by this definition, a to the x ln a. And we have used the definition of the derivative of the natural log of a function, such as this one here, ln fx, then the derivative will be the derivative of the expression inside the natural log divided by the expression itself. Now we're going to take a look at this one here, 5x squared. So is the index of the power is x squared. Find dy by dx. We're going to apply what we learned so far. So the first thing we need to do is to take the natural log to both sides. So we're going to say ln y on the left hand side is equal ln 5x squared. And then we're going to apply the power rule for logarithm. That will allow us to move the index with the power outside the natural log. So it's going to be x squared ln 5. And then we take the derivative of both sides. So we're going to say ln y, or ln y dash is equal to x squared ln 5 dash. All right. And then, as we are familiar now how to differentiate this one, is going to be y dash following the definition divided by y is equal, and then we differentiate this one here. So this is a constant, ln 5. It's going to be just this one here, differentiating this one will give us 2x. So that would be 2x ln 5. All right, so let's put it all together now. Multiply by y, so both sides. So you can see I'm doing it slightly different. I'm moving this first, y here, getting rid of the denominator by multiplying by y. And that will give us y dash is equal to x. Let's insert it between the x and the natural log 5. So that is 2xy ln 5. Now we know y is 5x squared. So let's place it in there. So we have y dash is equal 2x and then times 5x squared and then ln 5. And then we have to rewrite this one using the normal notation dy by dx. So dy by dx is equal to x times 5x squared ln 5. And that's your answer. All right, now that we are more familiar and confident with differentiating exponential function, I think it's a good idea to come up with a very short way or quick way to get to the answer, certain way, without having to go through all these steps. And that is the aim of this part of the video, is to kind of generalize it, okay, regardless what's the expression or the function at the power there. So if y equal a to the power of f of x, so that f of x could be a polynomial, could be a quadratic, linear, it could be trig function as well, it doesn't matter. So we can generalize a formula for this type of exercises. What would be the derivative dy by dx? That is the aim of our exercise here. Well, if I take you back to this exercise, that 2x there, if you remember, is the derivative of x squared, the power. So the first thing you need to do is differentiate the power. Remember, I call it f of x here, so we need to say f dash, okay? And then times it by 5x squared, which is this expression, which is the function itself, y. So times it by y. So again, I'm going to keep it as y rather than times a to the power of x. I could do that, but just to keep it short, write it down by y. And then times it by the natural log of the base of your function. The base of our function here is 5, and the base of our function here, the general form of function, is a. So we're going to say natural log of a, and that is the method or the rule or the definition we're going to, or the formula we're going to use from now on. So let's see with a different example how we can use this without going through the steps here. All right, so here we are. We got this function we're working with is 5 to the power of sine 2x. We need to find dy by dx, basically differentiate this. Okay, so this is what very useful if you are studying this function and you're looking at the turning points or the stationary point. So you need to differentiate dy with respect to dx. All right, and you do not need to go through all the steps to working out. You need to get straight to the expression and then study it further. Okay, so again, here's the general form we come up with. So I need to define my function f. The first thing I need to do, f of x is sine 2x. And then I need to find the derivative of that function f of x. Well, in this case, if you're familiar with differentiating a trig function, you would differentiate the inside of that trig function, in this case 2x, the derivative of 2x is 2. And then you multiply by the derivative of the function, the trig function. In this case, the derivative of sine is cos. And that's the answer. And that's it. That's it. What I need to do. That's all we need to do. We got the y, which is, let's write it down here. Our y is 5 to the power of sine 2x. And our base a is 5. So let's put all this together to come up with the expression for dy by dx. It's going to be the derivative, this one here, 2 cos 2x times y, which is 5 to the power sine 2x, and times it by natural log of 5. Okay, and that's it. Now, just be careful here. The 2 and the 5 here, they cannot be multiplied together to give you 10. They are separate entities. This is a base. This is a coefficient of this trig function here. So they cannot be multiplied together. All right, so that's how you complete or find the derivative of an exponential function. And that's the end of this tutorial. And I hope it was helpful. Thank you for joining me. Thank you for watching, and take care.